Hello everyone. So today we're gonna discuss about Docker. So what is actually the Docker and why we use Docker and what is the reason behind that means we need to take the help of this tool. Okay, so before moving forward, let's see why actually Docker came into the picture. So what is actually the issue, the problem so that this tool we thought to okay will go and will use Docker because it reduces so many issues while deploying any application. So as I said, deploying any applications means that the issue obviously came when we deploy an application. So suppose let me go with the pictures, some sketches here. So I will make two. Okay, so this one is for the developer side. This is for the developer side, and this one is off side. So suppose yeah, so developer has coded something. Suppose this HTML file he has coded here, and he has written the code. Okay, so developer coded, and whatever the dependencies, if it's code in a PHP and SQL is needed, database is needed. So all the means dependencies, libraries. So developer coded its dependency with the library dependency it is having with all means whole package developer created. Now the whole package is now sent it to where for the testing, and after that, as you already know what is the SDLC. So as per that process, developers sent everything to offsite, isn't it? Now the same code developer, okay, same code developer got here. So he received, but the issue now came. Maybe at the time of deployment or the release, ops people said that no, it's not working in my system. So where is the issue? What's the issue? Ops I checked everything. It's looks good. Everything looks good. So then where is the issue? Again, he has given back to uh, developer, and that can you please check once again if any issues with the code or something. Developer again checked and he told no, it's working fine for me. Uh, Probably from your side only some you know bug or something is there. So can you please check from your end? And again he has given to ops side. Again ops have checked, and this is actually kind of conflict came that no, in my system it's working, my system not working, no, again my system working again. Means after so many hustle, maybe we means ops or dev side somebody came out with a solution that maybe some issue with compatibility, maybe it could be from OS compatibility side. So like these stuffs came here. So this is the issue, and as you all know, then we came across, then we took the help of DevOps tool, where Docker came into the picture. So this is how the Docker tools we feel to okay, now this is the time to use this tool. So basically, what actually it was before? How's the architecture? Means what's before the Docker? As you already know, the virtualization technique. So where we will virtualize our environment. So before it's like, okay, I'll just keep here. Okay, so virtualization came when actually before virtualization also we have a physical data centers, and we used to provision those servers, and then we will deploy our applications on that. Then came virtualizations where we, if suppose we have one physical server only, this is a hardware, and on above on that uh, we have OS. Okay, so now, so before virtualization, this is only these two where the architecture where we used to deploy the applications, and again there is a lot of issue. There's a physical server and it's a cost effective also. So this is very costly. That was very costly. So then virtualization came into the picture, and we have installed VM, virtual machines, and then on machines we have uh, provisioned the servers. I mean, sorry, the yeah, you can say server, or you can say, you know, OS. So suppose this is my first OS, and this is my second OS. There could be n number of OS. It's not like one, two, three, this much. There could be n number. Okay, so these all are OS. Means on our VM we have different OSs where we used to deploy our applications with all its dependencies. I mean, libraries and binary files and libraries, and same here. Okay. So this is what we have after our physical architecture. But again, this is, you can say, like a heavy weight. So again, you need some kind of CPU, some RAM here. So that is again a costly. So then came our Docker into the picture, where so everything is same, just what we have. So hardware will be same, OS will be same. Instead VM we have Docker engine, and instead of different OS, you can directly go with your deployment of applications. No OS required now. Yes. So yeah, so Docker engine, here is a VM, here's a Docker engine. VM required another CPU, RAM. It will take some part of your physical RAM, your CPU, your hard disk. So there is there are kind of heavyweight. That's why I call a heavyweight. And again, if you will reboot any server, then obviously it will take at least 1 minute, maximum to 5 or 6 or 7, whatever. It depends on the server. If it will hung, then obviously it will go. You need to again fix it. But the problem with that was a problem with VM. But our Docker engine, no, nothing like you need to take any CPU, RAM, nothing. It will take a part of your kernel, a very small part of your kernel, and on that only it will create a container, and yeah, go with your applications and run whatever you want to. If you want to deploy, you want to create applications, you want to run applications, do it. So that's why it is called a lightweight. So there is a simple overview of Docker. So again, what is a Docker? So you can say a Docker is a tool, a DevOps tool, or a tool, or a plat, or a set of platform as a service, a kind of DevOps tool, which, okay, let me explain with example that will be good. Okay, so go here. So suppose if this is a Docker engine, okay. So as I told, a Docker is like a tool. Is not like a tool. It's a DevOps tool. It's a DevOps deployment tool where you can create your applications. Black is not good. All the black is my favorite. Your different applications here. Okay. So Docker. Let me write something. Docker. So Docker is a tool which have one you where you can create your applications with all the dependencies and what are the libraries, and so Docker is a tool where you can create all the applications, and after that you can run those applications, and obviously you can you know deploy your applications. So I have deployed on internet. How? By making use of container. So again, a concept called container. Okay. Yeah. Okay. So what I did now, as I told, a Docker. Okay, so Docker is a DevOps tool, which from where you can create, you can run your applications. So these two are my applications, and you can deploy those applications on the internet. How? By making use of this container. Container. Yeah, and that's it. This is what the Docker. And this container will have all the dependencies in the libraries which is actually required for the particular applications. And this is what the Docker means. Not brief overview. So what's the Docker? And yeah, this is what we have discussed. There's a conflict. So why this conflict? Because whatever the dependency libraries, it is not compatible here. So we have used this container actually, which gives you to use applications no matter what is your environment, no matter which uh, you know no matter if any dependency is lacking from ops side or a developer side. just unit those containers and yeah, go and you can do your work. So this is all about Docker. So now we will see how to install Docker, how to run Docker. And one more thing, suppose you have any, okay, so for Docker, what you need to do, you need to get some image of your uh, now suppose let's take an example like I want to deploy any applications. So obviously we need to make as a we need to make use of web server, isn't it? So suppose I want to make Ubuntu as a web server. So obviously first of all I will pull one image, one Ubuntu image, where from the remote repository, which we also call as Docker Hub. So before moving further, you need to create account in a Docker Hub so that you can pull any image, push any image. So suppose I will write here Ubuntu. So as you can see Ubuntu, and you can see updated an hour ago. So they are so active. You can see downloads 10 million plus and 10,000 plus stars. So this is a very good thing that it's updated. They this Docker peoples keep updated their resources every minute, every hour, like that. So yeah, it's a good platform. So you can see, you can explore more if you will just create one account. And even though you can put your own image also, I mean to say that if you have, this is a Ubuntu, okay, OS, and you have pulled this image into your you know, this is my system, this is my host operating system. You can pull those images, means Ubuntu, and you can modify that OS, and again you just push to this repository so that you can make it easy, make it use later. And one more benefit of Docker is that whatever the size of Ubuntu you will get while installing in your host machine, just compare that. We will gonna see in a few minutes. Just compare that size, and if suppose you are taking, I'm just giving an example like 10 12 GB with all the dependencies of the Ubuntu, and you have um, you're using this Ubuntu as an image, and you have Dockerized this image, and then see what's the size of the Ubuntu. So let's jump on to our EC2 instances. So this is my Ubuntu host operating system. So here I will install my Docker. So docker Docker. No. So what you need to do, as I have already installed Docker here, so you need to install first this Docker apt-get install yes and docker.io. So when you click this one, it will install, as I have already installed, so it is giving all the zeros. Okay, so just install it, and you can check with Docker version. That's great. Now as Docker is now installed here, now we will start. So as I told, we will first write a command to pull an Ubuntu machine. Okay, so Docker pull Ubuntu. Okay, so actually I have 1 second. Mm-hmm. Okay, actually I have already Ubuntu machine, so means, see, if I'll run this Docker pull Ubuntu, so first it will see is it available in my local repository or not. If it is there, then it will pull from my local repository. If it is not there, then it will pull from the remote, that is at docker.com, means from the remote repository. So what I will do now, I will delete Ubuntu. So this is a command. So what I want, I will delete all these images. So how to do? Either you can type docker remove image, and if it will, maybe the docker means whatever you did, that image is running. So if it will not gonna remove, you just give hyphen f as a forced removing the docker image. Or one more command is you no need to means worry about the particular docker image. You just run this and all the images will be cleaned out. So docker remove image hyphen dollar docker images hyphen q and just run it. Okay, so it's stating that it cannot be moved because image is being used by running container. Okay, so how to see how many containers are there? So just write docker ps. If you write docker ps, it will say these are the containers. These are the containers which is actually running at present. And if you want to see all the docker containers, then type in ps hyphen a. And yeah, the running as well as all the docker, I have only 2 docker containers. So what I'll do now, I'll just delete all those containers. So docker remove ps, or better to use docker remove hyphen f dollar docker ps hyphen a hyphen q. So it will remove all those containers. So you can see AAA CF and D59E D59. It is removed. If you will check now, docker ps hyphen a, I don't have any container now. So docker images, okay, docker remove images hyphen f dollar docker images hyphen q. Yeah, it's done. So now if I'll type docker images, see, it is clear now. So docker, now I don't have any Ubuntu image in my local repository. Let's see what this docker will do. So docker pull Ubuntu. So see, Ubuntu default latest, so obviously it will pull all the latest whatever the Ubuntu images were present. So latest pulling from library slash Ubuntu, pull complete. So download it. So what it actually did, so it pulled actually all whatever the Ubuntu image is there, it pulled from this library docker.io library, and the version is the latest one. So now if I will check docker images, yep, I have one image. Now so okay, now what about the docker container? Obviously it should not be there because I have not containerized now. Now let's containerize them. So clear it, docker, the command is docker run. I need to run that image, that Ubuntu image, to containerize this Ubuntu image. Docker run hyphen it, which is the interactive mode, and hyphen d hyphen daemon means it will run background, then Ubuntu, as this is the name of my image. Okay, so this is my container ID. Let's check. So docker ps, okay, so this is running, and if I'll give hyphen it, oh okay, so same. Now this is my Docker container. So now it's like a OS for you. So what is container actually? So container, as a name suggests, only it will contain something, isn't it? So if you have a container, you can keep it inside the container many things. Now this is like a container, I mean this is like that container only, where you can keep it many things inside of this container, and yeah, you can make a use of it. So what I'll do now, I will do one thing like, so this is my container, means this is my container. So I have deployed here applications. So what I'll do, instead of this applications, I will deploy one service, that is Apache service. So let's say Apache Apache service. So then my Ubuntu server will be now Apache Ubuntu server, isn't it? So we'll make our server as a web server. Okay, so let's jump back here. Okay, so this image actually will have all the what are the okay, one more thing, just observe this one, Ubuntu Docker images. Okay, so as I told you, if you will install Ubuntu in a host machine like Ubuntu what from the ISO file or something, you will get your size in GB obviously. But here just observe the size, 64.2 MB. Isn't it a good characteristics of containerization, I mean Dockerization? Yeah, it is 64.2 MB. That's why it called lightweight. So we have saved a lot of spaces here. Okay, so now I have the container. You can say like it's a Docker PS. It's a OS only. So let's go into this OS then. So the command is docker exec -it, copy this container ID and bash mode. Okay, so now we came inside this OS, inside this container, inside this Ubuntu. Now again the same procedure, apt-get update. See, everything is same here, how you are doing for your main operating system. Okay, it's done. Now I will install Apache. So apt-get install, I'll give yes, Apache 2. Great. So it is installing all the files for this Apache. Okay, yeah, it's done. Let's clear it. So let's check the service Apache 2 status. Okay, it's not running. Okay, we'll keep it like that. Exit. Now what we did, now we have containerized, I mean we have made this Ubuntu as an Apache Ubuntu server. Now what we'll do, we will, as I already told, we can customize our own image. So let's make our own image. We have what is this image now? This image is Ubuntu Apache, so we'll give name also Ubuntu Apache, so that we'll keep remember. So how to do that? So before that you need container ID. So docker ps, yeah, if you will give docker ps -a also same, because I have only one. Now docker, to making your own image, command is docker commit. There is a keyword docker commit. Take your container ID, paste it here, and you need to give your new image name. Okay, so my purpose is like I will make my own image and I will push my this image to my remote repository, to my local hub account. So if you have such kind of target, then you need to tag your username also. My username is DevOps31 because I have created with this name only my Docker Hub account, DevOps31 forward slash, and now you can give your image name. So I'll give Ubuntu hyphen Apache, and let's run this one. Okay, so we have successfully created. So this is the image. Let's check Docker images. Great. See, we already built a successful one. Is something affected on Docker container also? Let's check it. No, there is only one. Okay, so now we have image. Okay, now let's see if we have installed Apache on our Ubuntu server. So let's see whether Apache will be, if we will publish, if we want to see whether, yeah, suppose any HTML file we need to, any website I need to expose on internet, so how we will do. So before that that service should be exposed. That service we can see on internet, isn't it? So what it will do, we will make this image as a container. So let's containerize it. So docker run -it -d and your image name. This is my image name. Okay, so what we will do now, we will create a container of that. Now we are actually running and deploying that images. So the deployment should be on some port, isn't it? So we will give some port, as Apache will run on 80 as a default, so we will expose on another port, say 82-80. Okay, so docker and -it -p-d, correct. Let's run it. Now we got the container ID, and let's get into this container. Docker exec -it, this container running bash mode. So let's check the service Apache to status. It is not running. That's good. Now what we will do, we will copy and we will see first here. Obviously it should not work. Correct. Now again jump here. Now we will run and let's see. Service Apache to start. Okay, so now status is running. Let's do this one. This is what we actually want. So now our web server is ready. Now you can, means anyone can do whatever they want to do. So located means if you want to do any web page here, so you can make it here. Okay, let's do that also. So ls, so cd hyphen www hyphen html. Is there any file? Index.html. What is that? No. Index.html. Okay, let's get index.html. It's So this is what the content here. Okay, we'll make our own HTML file, and let's see if it will work or not. Nano one dot. Okay, so this is 82 port. Let's try something index.html. That's great. Now this is what I want to show you. We'll make some hello.html file. Okay, it is saying nano hello.html command not found. No problem. So touch hello.html. Okay. Nano hello.html. Again same vi